So another application I want to consider is total distance, and in particular, being able to distinguish total distance from displacement. So if you think about a car traveling along, say, the x-axis, at any moment in time, the driver can determine how fast they are going by looking at the odometer. This is called the speed. So we're going to refer to this within this video as speed of t. And that's going to be the speed of the car at time t. However, if you're only looking at the odometer, the driver cannot tell the direction in which they are traveling. So if you want to indicate direction, we need to multiply the speed by plus or minus 1 if we establish some direction as being positive and another being negative. We call this the velocity, say velocity of t, of the car at time t. And both of these things have the same units. So for instance, kilometers per hour, miles per minute, anything like that. And the connection here that I want to make is that speed is equal to the absolute value of velocity. So this velocity indicates direction. Speed does not indicate direction. So that's really the distinction there. So if we now start to think about what happens if I integrate speed versus if I integrate velocity, what we want to think of is, sometimes you go back to, say, like a Riemann sum if you're considering this. If I'm going to add up, say, rectangle areas, in the velocity case, there's going to potentially be some cancellation if you have negative and positive values. But speed has all positive values. So if we aggregate the information with speed over a time interval, that's going to produce the total distance traveled by the car. So it's not going to have any kind of canceling out if you turn around. So one of the things we'll look at here is that the integral from a to b of the speed function is going, I should write dt. That gives the total distance traveled from time A to time B. So if you integrate speed, you get total distance traveled. However, if instead you integrate velocity with respect to t, that's going to give you what we call displacement. It tells you how far you are from where you started. And this is again from time A to time B. So integrating velocity gives us displacement. So more often than not, in these contexts of these problems, you're given velocity, you're given some indication of direction. So in most of our applications, it's going to be a little bit harder to find the total distance because that involves taking the integral of an absolute value. So we need to be careful with